When pursuing a degree and/or career path in mechanical engineering, understanding the day-to-day of the position is a key step in providing clarity that it is the best career path for you. What are the daily tasks? What are they like? Do they involve a lot of work at a computer, or in the factory, or in meetings? Today I will take you through a typical day in the life of a mechanical engineer. Let's call our engineer Robert. He's a design engineer working mechanical design on an Amazon delivery drone, and we will follow along what he does today. And although I've never worked at Amazon and I don't have an exact blueprint of what it looks like working this position at Amazon, but I do have experience as a mechanical engineer and can give you a good hypothetical insight on this. But before we start walking through Robert's day as a mechanical design engineer, be sure to hit the like button and subscribe to this channel to hear more about what mechanical engineering jobs are like and the best ways to get into them. And also be sure to stay to the end of the video so you can get a clear, realistic understanding of what a typical day might be like, as I intend to try to be as realistic as possible here. I don't intend to try to hard sell you on the opportunity of mechanical engineering, but more to help you decide if it's right for you or not. And that's why we'll start with just a typical thing that everyone does when they start a work day, which is to check emails. And so Robert looks through his emails for what's important. He potentially ignores ones that don't matter, maybe are just mass emails to his entire group that don't apply to him and stuff. But he does see this email from his colleague, Sarah, who was working as a structural analyst on the same program. And Sarah's asking him if it's possible to increase the size of the rotor shaft on the drone because she was finding some fatigue issues with the life of the drone with its current size. And in this email, she put some images from NASGRO and some charts showing this. And so that's why Robert goes in to look through the CAD assembly. You see this assembly with the rotor shaft and its bearing and such. And he looks, what are some constraints he has? Is there anything stopping him from making this particular geometry change? And also it needs to be within the mass budget for the assembly, because if he increases the size of this shaft, then that would also add more mass onto the entire assembly, and also just this sub-assembly as well. And he finds there is a little bit of rearranging in here to do to compensate for that size change. And that takes up a little bit of time. As a mechanical engineer, sometimes if you have to accommodate changes that someone else needs on your same design, then just take some time to find creative ways to make that work, or rearranging things and such. So he looks at that, and then he also has to work on an avionics panel. And so putting together the preliminary design, giving the size it'll have to be, and what all components have to fit on it and such. He meets with his team about this design, discussing what the selection of materials for the panel would be given the loads, the loads that might be on it, and the size it has to be and such. And there are some decisions to be made there, and seeing the feedback from his supervisor and from his teammates and stuff. And then Robert also goes out into the I&T floor, checking on the assembly processes with the primary structure of the drone. And he communicates with the manufacturing manager and a few technicians, and they exchange what's been going on with their side of the job, with Robert's design side, and the technician's side of having to put everything together physically out on the floor. And they did find that one part of the frame has been found to have an interference during the assembly. This was not something that was expected while they were designing all this and assembling all of it in the CAD assembly. So Robert will need to update this assembly and make documentation to solve this problem, and see what they could do about it to make it work out properly. So looking back through his CAD assembly and the drawings, he finds a different way to assemble everything that should work properly. He sends an email about this and communicates with them to see what they think. And in this case, they think that it should work well, and so he gets the go-ahead, reinitiates the release process for the new workflow for this particular assembly. Because that is something that design engineers especially might have to do, is they're dealing with not only just does everything seem to fit from a CAD perspective, but how would you get it to fit in the physical sense while the technicians are putting it together on the floor? What kinds of manufacturing methods would they use, or assembly methods? Is this actually possible with the equipment you have? All that. There's a lot to consider, because this isn't just a textbook problem that is super simplified. You have a lot to consider about, does this fit, and is it possible to actually put it together given the resources we have and just the reality of how things go together. And so when Robert has a chance to get back to looking at the rotor shaft, he does rearrange those few things and selects a larger bearing to accommodate the larger size shaft. Then he emails Sarah, the structural analyst, and new dimensions, and so she's going to go ahead and take those new dimensions and the new geometry that he sent her. She's going to put it back through all the analyses she's doing, probably also the static analyses unless someone else is doing that, and just all different dynamic, linear, nonlinear, etc., things that she believes are relevant to this particular situation with the design, and also just those same fatigue criteria to see if that could work in this case. She may have looked into that before. She may have inputted a particular size of rotor shaft and then said, well, that one would actually work. So, hey, Robert, can you actually increase it to this? Because I know that works. But there'd probably also be other things to consider as well. Sometimes you have to check tons of things, and good to do some communicating between design and analysis, but also check things preliminarily at first as well. So that's like sort of a sample of what a typical day in mechanical analysis could be, in mechanical design and analysis could be. Pretty decent variety of tasks depending on which company it is and the size of the team and how varied your responsibilities are. But yeah, you deal with a lot of designing things and making sure everything works properly, fits together, and making sure it's good with the analysts and making sure it's good with the people on the floor and everything. And I hope you found this video helpful, and I hope you get a sense of what a typical day might be like, and if you see yourself potentially doing that day multiple times throughout the rest of your career. And if you found this video helpful, please be sure to hit the like button and subscribe to this channel to continue getting some good insights about engineering careers and whether or not to go into it and how to succeed in it and everything. And I wish you the best of luck in everything, and we will talk soon.